semantic search has a lot of advantage compared with keyword search. And as large language model is becoming popular, we may also want to leverage large language model to generate the answer for the query. We can see generative AI has a lot of advantage and can create significant business value. For example, it can create new experience, improve productivity, and can extract insights from corporate information, and it can also create new ideas. But generative AI also have some challenge, especially for enterprise customers. For example, the foundation models used by the generative AI is trained by static and dated knowledge. And the data set used for the foundation model is public data. It doesn't have knowledge on the enterprise data. And the third shortcoming of large language model is hallucinations. That means it may generate some incorrect information. So how to mitigate the hallucinations? There's some technologies such as one-shot or few-shot prompt technology, and we can also use fine-tune technology to tune the model with your corporate data. And we can also leverage in-context learning and provide more context information to the large language model. Retrieval augmented generation, or RAG, is one of the technology of in-context learning. So for RAG technology, there are also two important components: retrieval and augmentation. And for the retrieval components, we just use embedding technology to convert the text into vector and store the data into vector data store. And if a user submit one query, and we use semantic search technology mentioned before to retrieve relevant documents and combine the relevant documents with the query as context to large language model, and then use large language model generates the content and return the result to end user. We can further enhance the RAG solution with memory information. That means we can store the conversational history. For example, we are trying to chat with your knowledge base, and you may ask one question about OpenSearch best practice. So the question is how to determine shard and data nodes for OpenSearch. And the RAG solution can provide some information or answer to you like this. But you may have follow-up question. For example, your follow-up question is, if my data growth is very fast. So you can see the your follow-up question is assuming you ask the question with the context. You are still ask about the OpenSearch best practice. And with conversational search, it can correlate the questions together and provide the answer to the end user. To implement conversational search, it still use the RAG solution. The difference is it adds chat history into the overall architecture. You can see we use the chat history to store the history conversation. So the benefits of conversational search is it can answer your question with enterprise data. So the result is more relevant and accurate. Second advantage is it can involve knowledge base in real time. It's not static. With conversational search, you can also reference to the source data and validate whether the information is correct or not. And the last is it is in context conversation. So this is a conversational search reference architecture, and it also has retrieval component and augmentation components. Now for the retrieval components, just like RAG solution, it converts the text or knowledge base data into vector and store that information into vector data store. And for the augmentation component, it will combine the original query and the semantic search result and conversational search history together as input to large language model, and then use that information as input to large language model and generate the result. So that's the basic concept technology introduction. So let's look at the workshop content. So in this workshop, we have 8 modules. So the module 1 is search basics. It will introduce keyword search basic concept and the semantic search basic concept. And in the module 2, we'll do some lab. And in this lab, we use Jupyter Notebook and OpenSearch service. And the Jupyter Notebook is just like a client interact with OpenSearch service. And then module 3 is semantic search. And in this lab, we use 3 technology: Jupyter Notebook, SageMaker model, and OpenSearch service. And we use Notebook as client to load the bot model and then convert text into vector and store the vector data into OpenSearch service. and the client then submit query to OpenSearch service to semantic similarity search. So the first module is full stack semantic search, and we will implement the semantic search from front end to the back end. You can see we will develop some web page. The web page will call API gateway and Lambda, and Lambda will call the SageMaker endpoint and return result to the front end. So this is just a full stack solution for semantic search. And module 5 is fine-tuning technology. And to build more accurate search results with semantic search, you may fine-tune your model with your enterprise data. And in this lab, you will learn how to fine-tune the model. And the other components is very similar. The difference is we just fine-tune the model to improve the search relevance.